Hi, I'd like to give a brief demo of what a job control shell does, and here specifically I'm using the job control shell that is currently part of our first project. It is in many ways similar to the bash or other job control shells. Okay, so first of all, your shell should support the ability to run commands, right? So for example, if I type ls, it should be able to do that. Um, Moreover, it should be able to wait for a job to finish. So if I type sleep as a command that makes the sleep system call 5, then it should not return to the prompt until this foreground job has finished. However, if the user starts it in the background, it should return to the prompt immediately. And in this case, it should output the assigned job ID as well as the PID of the process that was started. Okay. Moreover, it should then be in the jobs list. Okay. So in this case, we have one job running. We could start another job. Both of them are. And then if the first job would exit, so in this case after 10 seconds, then it should be removed from the jobs list. Notice I'm not outputting anything, even though as I'm talking, the job is already finished. If I hit enter now, that's when I get the message. This one is still running. I'd enter a few times. That's okay if the reporting of the job is a little bit delayed. Okay, so this is foreground and background jobs. Now let's talk about job control. Okay, so what if a shell, what if the user starts a process in the foreground? I'm going to be using the sleep example here frequently, and that changes their mind. In this case, they can type ctrl-z. This puts that process into the stopped state. Okay, so it's now stopped. Now the user has two choices. They can bring it back into the foreground with this, possibly move it back, or they can also put it in the background where it is now running. Okay, but it doesn't. But it's not in the foreground. It doesn't have control of the terminal. It is not assigned the foreground process group ID as far as the terminal is concerned. Okay, so let's look at more examples. So what about pipes? So you should be able to type, for example, ls, and we pipe that into another command, word count. Pipes can be longer. We can use the cat command because it doesn't do, it just forwards the output. They could be written like this. Commands that are part of this can be given command line arguments as an example, right? I can do this, which would do ls minus l and pipe the output to a grep and find out output only those that match this. Pipelines can also be sent into the background, by the way, in which case the the prompt would return immediately. You notice something here is that despite the fact that this pipeline was sent to the background, it was still able to run and output its output. That is because if a program just writes to its standard output, and the standard output is a terminal in a normal fashion, that is still possible even if the program is running in the background. You may observe that sometimes you start something in the background and you still see its output go to the terminal. However, there are certain operations that the program cannot do while it is running in the background. I'm going to show you one. So for example, if I run the Vim editor here, starts the Vim editor, I can edit a file here. But what would happen if the Vim editor were started in the background? Let's try that. So in this case, first of all, it doesn't start, and we see that the Vim editor here was stopped. Okay, so it's actually only one because the my shell outputs the stopped message here, and that was delayed till I typed the job command here. So now that the Vim process is stopped, okay, another user when it puts it back, it is placed back into the foreground, and the user can continue here. Okay, let me stop it again, and we see that it is stopped. The user can also use built-in commands like kill. Okay, so for example, kill one sends the kill signal, and now job number one terminated, and so now our jobs list is left with this one. We can probably also kill job number two, and see if that terminated. It did not. Actually, Vim decided to ignore this. Okay, so let's see if we can. Now this my building command does not actually not support that. Right, so I would have to say use the user bin command, and now it would interpret this as the PID. Okay, so let's see. I have to do user bin kill dash 937 935. Okay, and now killed, and Vim is gone. Okay. So this is my shell. You can customize yours better. That's why it's called cush, customizable shell. But it shows some minimum required interaction. Next, I'd like to show you the redirection facilities of the shell. So at the minimum, when you type ls, you should be able to redirect this into a file, and then we see this this file. You should also be able to redirect standard out and standard error. Okay. Now for a program like ls, which normally doesn't output anything to standard error, you may not see the difference. Okay. But let me show you another program which I call write to standard error, which outputs a little bit to standard out, a little bit to standard error. If we run it like this, we do not see any difference, right? First the standard output, output, and then the standard error output. But if I redirect this into a file, we would see the standard error output still go to, in this case, the controlling terminal, and only the standard output redirected here in this case. But the shell would also support the redirection operator with the greater than ampersand to t. In this case, both streams would be redirected. This also works if when combined with pipes. Okay, so if I do this, then I see the standard output. But if I inform it that I want both standard output and standard error redirected, then we would see both of them being redirected um, to this file. Also should support reporting when processes terminated with a signal. Okay, so I want to show two examples. A program that just essentially raises the circuit board signal. If this program is run, then the shell should output this, right? A program that dereferences the null pointer, when this program is run, the shell should output the signal that caused it to terminate. Okay. Now the shell should also output something when it itself wasn't the one that caused something to terminate. Notice it just observes it. So for example, if I run a sleep 300 and then on the same machine, I'm going into another terminal here where I'm actually running bash, and I am terminating this process here, which is, you can see, is a child of our shell, then um, this process would be terminated. Well, the shell would report that as if it had died from a terminate for any reason. In general, the customs are, so if a process just runs to completion, we don't output anything. If a process is ctrl-z, then typically we also don't output anything. I think that's a custom at least. If a process is stopped, we output a stopped message. And if a process is sent to the background, okay, then typically when that process terminates, a done message is useful. So if I send this process to the background, then one to it would have terminated, and then here's the done message that is being output. Notice that your shell should, when it kills a process, it should not assume that this process dies. Okay. Now, let's say if I'm going to let me write a program. I'm going to call it unkillable. Is maybe too strong of a word. Uninterruptible. Okay. So if I write this one here and maybe this process is just going to do an infinite loop, but before it does that, it would ignore the sigint signal in this case. Okay, so I'm probably going to need to include signal.h in this case um, and make that. So in this case, the program here, if I run this program and I type ctrl-c, you see nothing happens because this program chooses to ignore it. So if I'm terminating this here with this kill, it will be terminated. In this case, by the way, sig term is being used, not sigint. Now, the what if this program were started in the background here? Okay, and now let's say the shell built-in command implements, we say kill one. Okay, so in this case it is terminated because I implemented it correctly. But let's say what if this ignored the sig term signal as well? Okay, in this case. So in this case, I would run it in the background. Yeah. And now if I killed this, it wouldn't actually die, okay? So what your shell cannot do is, just because the user typed kill, okay, it cannot assume that this process was actually terminated. It cannot do that until it gets notification from the OS that that was in fact the case, okay? So now let me kill this. And now, in fact, it was killed with -9, which is not something that a program can block. One additional requirement I want to alert you to, this is important for the tests. If a process is run and then it is stopped, and then it is later put back into the foreground, at this point, you are expected to echo back, in this case, sleep 30, which was the name of the command that was originally run. If you don't do that, the tests will not work because they expect your shell to do that, right? This is incidentally also something that bash does here in this case. So now the user knows what is in the foreground as if they had typed it on the command line. Finally, let me show you that it's also possible to combine commands on the command line. So I can say, for example, ls type pipe wc, but I can combine this and I can say, like echo hi sleep 2 echo done. In this case, your shell should execute those commands one by one. Okay, so should run this, wait for it, run this, wait for it, and so on, unless it's being sent in the background. Okay, so for example here, if I typed ls this echo hi and then sleep 4 in the background and then echo done, then we would see a done output right away, and this would have gone into the background as a background job. Okay, so multiple commands can be combined. I think it's even possible to use the ampersand as a separator in this way. Furthermore, so the shell also supports double quotes. Okay, so if you, for example, if we do um, ls here in this case, we can also use double quotes, and that's useful if we have file names that contain spaces. Okay, so for example, what I can say is, the out if I type it correctly, the output, then the standard output of this file will be in here. And so if I do this, then we can see indeed that this file now has this now the command completion that is enabled does not work. So we have to actually specify this, right, on the bash. is a bit smarter. It puts an ampersand in there, but it's something you can implement if you want to. Here's some things that are possible nice addition, right? So you may notice that in Bash you can say things like if you said echo shell star or asterisk, you would get all file names that match this. Okay, whereas if you did this here, okay, you would not do that because this is something that the shell does. My shell hasn't implemented this yet, but this is a possible addition to your shell. In general, if you have questions about, what should the specific syntax, what should the shell do, and so on, the intent is for you to, be creative and have ideas of what your shell should do. Now, if that conflicts with the automated tests that we have, then we ask that you use the format that is prescribed by the automated tests. Um, the tests expect a certain output format which is described in this file, and you can change this file if you want to change this. But generally, we recommend that you do not do this. So this describes, for example, what the built-in command look like: stop, kill, foreground, background, and so on, as well as a few other things. And then one hint to see what's going on during a test. So if I'm going to exit the shell for this. If I am running the tests in this case, so I could run the tests like this. Okay, it would run the tests. But if I wanted to see the output during a test, I would do that as follows. Okay, let me show this. So let's say if I wanted to just run a single test, so maybe the ctrl-z test in this case. Okay, you can run a single test in this case. Um, you can change the output spec file and put the last one in here, comment this in, and then run this. Okay, and what this did was it now created a log file that showed what was going on during that test. Okay, so in this test, just to show you this, what was done with your shell was the following. Okay, so first the user typed sleep 60. Um, Now, then the user typed Ctrl-Z, and then the user typed foreground 1. That should have output sleep 60, and then the user typed Ctrl-C, and then the user typed exit. So this interaction that I had with the shell here in this terminal is exactly what this test tested. Now there's a little bit of a confusing part here, which is that the log file actually output logs both keystrokes that are entered into the terminal as well as those that are output by the terminal. And that is why you see the sleep 60 twice and the foreground 1 twice. Those are things that the user has typed and the terminal has echoed back. So those log files really give a complete log of the terminal. In fact, you even see the catch returns that are output as part of the terminal discipline. Okay, but this shows how to use the the output spec's ability to maintain a log file to debug the tests if you're wondering why is this or that test failing.